Hello, my dear students. How are you all? I am fine. I am Khandukar Fazder Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important creative question from chemistry second paper chapter 3 quantitative chemistry. So let's we start our online chemistry class. My dear students, this is our first stamp. Here given 25 ml 0.1 molar oxalic acid. This is solution A. 15 ml potassium permanganate. This is solution B, and 12 ml acidic ferrous sulfate solution. This is solution B, and all these solutions are equivalent to one another. And our first question is balance the reaction that occurs by mixing of B and C solution by ion electron method. My dear students, in this reaction between B and C, potassium permanganate is an oxidizing agent and acidic ferrous sulfate or ferrous sulfate is a reducing agent. So we write here, in this reaction KMnO4 is an oxidizing agent and FeSO4 is a reducing agent. Now, my dear students, oxidizing agent KMnO4, and we get from KMnO4 potassium ion and permanganate ion, and reducing agent ferrous sulfate, we get ferrous ion and sulfate ion from ferrous sulfate. So at first we write reduction half reaction in reduction half reaction permanganate ion MnO4 minus, it produce manganese 2 plus, and here 4 oxygen present, so we write 4H2O. Here we write 4H2O, that's why we write here 8H plus, and to balance the equation we write here 5 electron to balance the reaction. This is equation number 1. And now oxidation half reaction, that is present here 2 plus, it reacts and it donate 1 electron and we get ferric ion Fe3 plus. This is equation number 2. And to balance the electron we multiply the equation number 1 with 2 and equation number 2 with 10, and we write here 2MnO4 minus plus 16H plus 10 electron equal to 2 manganese 2 plus 8 H2O, and for equation number 2 we get 10 Fe2 plus minus 10 electron equal to 10 Fe3 plus. Now plus this two reaction, we get 2MnO4 minus plus 10 Fe2 plus 16H plus in left side, and in right side we get 2 manganese 2 plus 8 H2O plus 10 Fe3 plus. Okay, my dear students, this is the balance equation. Now we add the spectator ion in this reaction, and that is total reaction. Total reaction is permanganate ion comes from potassium permanganate. So we write here 2KMnO4 plus ferrous ion comes from ferrous sulfate. So we write here Fe 10 Fe2 plus, and this hydrogen ion comes from acid. If we write here sulfuric acid, then we have to write 8H2SO4. Now this sulfate ion reacts with manganese ion, and we get 2 manganese sulfate plus 8H2O, and if this ferric ion reacts with sulfate ion, then we get ferric sulfate. So we have to write here 5 Fe2SO4 whole 3, and my dear students, we see that here potassium ion is present, but in right side potassium ion is absent, because this potassium ion reacts with sulfate ion, and then we get K2SO4 ferrous sulfate, and this is the balance equation of potassium permanganate and acidic ferrous sulfate. My dear students, our next question is determine the amount of iron in C solution with the help of A and B solution. So we have to calculate the amount of iron by the help of potassium permanganate and oxalic acid. My dear students, we see that here given volume and concentration, but here only volume is present. So the concentration of potassium permanganate is absent, and so that we had at first we have to calculate the concentration of potassium permanganate. So in acidic medium, the reaction between A and B is 5 H2 C2O4 plus 2K MnO4 plus 3H2SO4, 3H2SO4, and we get 2 manganese sulfate plus 10 CO2 plus 8 H2O plus K2SO4. My dear students, this is the balance equation of oxalic acid and potassium permanganate. So, we know that volume of potassium permanganate, that means V KMnO4 into S KMnO4, that means concentration of potassium permanganate divided by volume of oxalic acid H2C2O4 into concentration of H2C2O4 equal to the mole number of potassium permanganate divided by mole number of H2C2O4. And here the given volume of potassium permanganate is 15 ml, 15 into S KMnO4 divided by volume of oxalic acid, that is 25 ml, 25 into concentration of oxalic acid, that is 0.1 equal to, here students see that mole number of potassium permanganate equal to 2 and mole number of oxalic acid equal to 5. So, we get SKMnO4 equal to 2 into 25 into 0.1 divided by 15 into 5, and we get the answer 0.067 molar. So, my dear students, we get the concentration of potassium permanganate. Now, the reaction between potassium permanganate and acidic ferrous sulfate, that means reaction between KMnO4 and acidic ferrous sulfate. We write here 2 KMnO4 plus 10 FeSO4 plus 8 H2SO4, and we get here 2 manganese sulfate plus 5 ferric sulfate plus 8 water plus K2SO4, potassium sulfate. From the equation we can write 2 mole potassium permanganate equivalent to 10 mole ferrous sulfate. That means, so we can write 2 mole KMnO4 equivalent to 10 mole ferrous sulfate. So, 1 mole KMnO4 equivalent to 5 mole Fe2 plus, because iron comes from ferrous sulfate. Now 1000 ml 1 molar potassium permanganate equivalent to 5 into 55.85 gram Fe2 plus, because we know that 1 mole ferrous iron equal to, or 1 mole iron equal to 55.8 gram iron. And now according to our stamp, we write 15 ml concentration of potassium permanganate was 0.067 molar KMnO4 equivalent to 5 into 55.85 into 15 into 0.067 divided by 1000 gram iron 2 plus, and we get the answer is 0.281 gram iron 2 plus. So the amount of iron in container C, so the amount of iron in container C is 0.2 is 0.281 gram. This is the answer. My dear students, this is our second stamp. We say that in container A 50 ml sulfuric acid present and 1.3 gram impure copper is dissolved in this container, and in container 2 here potassium iodide solution is present, and container 3 100 ml 0.2 molar sodium thiosulfate solution is present. So my dear students, this is our first question. How can the standard solution of the stamp be converted to the centimolar solution? My dear students, you see that in this container 1, here no concentration is given, and in container 2 here also no concentration is given, but in container C we get the concentration of sodium thiosulfate is 0.2 molar. So according to the stamp, this is the standard solution. Okay, my dear students, now we solve this problem. If we write concentration, if we write here volume of container C, volume of sodium thiosulfate V1 equal to 100 ml, concentration of sodium thiosulfate S1 equal to 0.2 molar, and a final volume of sodium thiosulfate is centimolar solution. My dear students, we have to convert this concentration into centimolar. So final volume of sodium thiosulfate, that is V2 equal to what? and final concentration of sodium thiosulfate, that is S2, equal to 0.01 molar, because the concentration of centimolar solution is 0.01 molar. Now, according to from dilution law, we get V1S1 equal to V2S2 and V2 equal to V1S1 divided by S2. So, 100 into 0.2 divided by 0.01, and the answer is 2000 ml. Okay, my dear students. So, here we see that water needed equal to 2000 minus 100 ml equal to 1900 ml. So, if 1900 ml water is added to sodium thiosulfate solution, then the solution will be a centimolar solution. So, we write here, so if 1900 ml water 1900 ml water is added to sodium thiosulfate solution, then the solution will be centimolar solution. And this is the answer. My dear students, our next question is use the solutions of the stem and calculate the percent impurity of impure copper. My dear students, we see that 1.3 gram impure copper is dissolved in 50 ml sulfuric acid solution. So, answer, in the stem, if copper is added to sulfuric acid solution, copper sulfate is produced, and the reaction is copper plus sulfuric acid, and it produces copper sulfate plus sulfur dioxide plus water. To balance the equation, we multiply here 2 and we get 2. Okay, my dear students, we see that from the reaction between copper and sulfuric acid, we get copper sulfate. Now, the produced copper sulfate reacts with the solution of container 2, that means potassium iodide, and we get the reaction copper sulfate plus potassium iodide, and here it produces 2I2 plus potassium sulfate K2SO4 plus I2. To balance the equation, we write here 2 and here 4. Okay, my dear students, and here 2. This is the balance equation of copper sulfate and potassium iodide, and this is reaction number 1. And this liberated iodine reacts with the sodium thiosulfate solution. That means this liberated iodine is titrated by the standard solution of sodium thiosulfate, and here this type of reaction occurs. Na2 H2O3 plus I2 and 2NaI sodium iodide plus Na2S4O6. This is reaction number 2. From reaction number 1 and 2, my dear students, we can write 2 CuSO4 from reaction number 1 and 2, we can write 2 copper sulfate equivalent to 2 mole copper sulfate equivalent to 1 mole iodine, equivalent to this iodine reacts with 2 mole sodium thiosulfate solution, that is 2 Na2H2O3. My dear students, here 2 mole copper sulfate reacts with potassium iodide and we get 1 mole iodine. So this 2 mole copper sulfate is equivalent to 1 mole iodine, and 1 mole iodine reacts with 2 mole sodium thiosulfate solution, and that's why we write here 2 copper sulfate equivalent to iodine I2 equivalent to 2 mole sodium thiosulfate. Now, my dear students, we can write 2 Cu2 plus equivalent to I2 equivalent to 2 Na2H2O3. So, now we can write here 1 mole sodium thiosulfate equivalent to 1 mole copper 2 plus, and that's why we can write here 1000 ml 1 molar sodium thiosulfate Na2H2O3 equivalent to 1 into the mass 1 mole copper equivalent to 63.54 gram. 63.54 gram copper 2 plus. We get 1 mole copper equivalent to 63.54 gram copper 2 plus. Now, here the sodium thiosulfate solution was 100 ml and the concentration is 0.2 molar. So, we write here 100 ml 0.2 molar sodium thiosulfate Na2H2O3 equivalent to 1 into 63.5 into 100 into 0.2 divided by 1000 gram copper 2 plus. Copper 2 plus. My dear students, and our answer is 1.2708. 1.2708 gram copper 2 plus. Okay, my dear students, now impure copper. Impure copper equal to 1.3 minus 1.2708 gram, and that is 0.0292 gram. 0.0292 gram. So, the percentage of impurity percentage of impurity equal to 0.0292 divided by 1.3 into 100%. That means the answer is 2.25%. So the impurity of copper is 2.25%.